Welcome to this lesson on permutations and combinations. Let's go over some vocabulary first. So an outcome is the result of an experiment or an event. A permutation is a way to find the number of outcomes when order does matter. Combination is a way to find the number of outcomes where order does not matter. And then a factorial is the product of a number and all the numbers below it until you get to 1. So the factorial of 5 is written 5 with an exclamation point. So 5 factorial, and that means 5 times 4 times 3 times 2 times 1. And that would be 120. So 5 factorial is 120. Don't go all the way to 0, of course, because then you'll just get 0. Okay, so let's talk about some examples and whether they are permutations or combinations. So remember, a permutation, the order does matter, and combinations, the order does not matter. So number 1, the ways to arrange the 6 numbers that open a locker. That would be a permutation because the order that you put in the numbers for a locker or any lock does matter. Number 2, ways to make a sandwich with these ingredients: ham, turkey, white bread, wheat bread, lettuce, and tomato. So in this one, the order doesn't matter. I can put ham and then turkey, or turkey and then ham. The order doesn't matter. Number 3, the ways to arrange books on a shelf. That would be a permutation. Number 4, the number of ways the letters in the word horse can be arranged. That would be a permutation. The order matters. For example, if I wrote the letters like this, that's different than if I wrote the letters like this. The letters are in a different number, and that's a different combination. Same thing with the books on number 3. If I have 3 books, let's say I have Beauty and the Beast, The Little Mermaid, and Aladdin. These are all Disney books. So that would be one way to arrange them, and then if I arranged them this way, that would be another way. So the order would matter. Those are 2 different ways to arrange the books. All right, number 5, possible winners when drawing 3 names from a box of 10 names. That would be a combination because the order does not matter. So if I draw the name Sarah, and then I draw the name Drew, and then I draw the name Adriana, all 3 of those are winners. But if I had drawn Adriana first, and then Sarah, and then Drew, even though it's in a different order, they're still all winners. So the order doesn't matter. Okay, pause the video now and try 6 through 9 by yourself. All right, 6, you should have gotten permutation. The order does matter because if I have, let's go back to the same people, Sarah, Drew, and Adriana, first, second, and third place. But if I switch them, someone else is in first place, that is going to matter to them. Number 7 would be a combination. Possible lottery winners when drawing 6 numbers from a pool of 50 numbers. So in the lottery, if you have all 6 numbers, regardless of the way you put them on your lottery ticket, it doesn't matter. You still win. So the order doesn't matter. Number 8, possible 4-digit codes for a home security system. That would be a permutation because the order matters. If my code for my security system is 2378 and I try putting in 8732, it's not going to work. And then number 9, possible license plates with 6 numbers and letters. That's a permutation, because the order on your license plate does matter. If it's in a different order, it's a completely different license plate in a different car. All right, so let's talk more specifically about permutations. So remember, in permutations, order does matter. And we're going to talk about some different formulas here. And the formulas are going to have a P for permutation, and then they're going to have an N and an R. So at the top you have what those mean. N is the number of things to choose from, and R is how many you choose. So let's talk about an example when repetition is allowed. So this is how you notate that you're trying to find a permutation, and this is the formula for that. So this is just the notation that's telling you that we are finding a permutation, and then this is the actual formula. Okay, so the example says, how many different ways can you arrange the numbers for a lock that takes 4 numbers? So how many different ways can you arrange the numbers for a lock that takes 4 numbers? Okay, so if you think about a lock is going to take single-digit whole numbers, positive whole numbers. So let's list those out. So a lock could take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether that is 10 numbers to choose from. And we are choosing 4 of those numbers. So if we are going to substitute these into our formula, so N is the number of things to choose from, so we have 10 numbers to choose from, and we want to choose 4 of those numbers. So 10 to the 4th power. All right, and you can use your calculator for this, and that would give you 10,000. So there are 10,000 different possible lock combinations, and even though we call it a combination, it's really a permutation. We should call it a lock permutation. All right, and then let's talk about when repetition is not allowed. So in this case, repetition could be allowed because my lock combination could be 3, 3, 3, 3 if I wanted it to be. So repetition would be allowed there. But let's talk about when repetition is not allowed. So remember, this is just the way to notate it. And then this is my formula. And I do have a little note. If N and R are the same number, then you can just use the factorial of N. All right, so there are 8 people running a race. So that's how many I have to choose from. That would be my N. How many different ways can first, second, and third place winners be arranged? So my R is 3 because I have 3 different places. I can't repeat. Sarah can't win first, second, and third place. So I'm not going to repeat. So I'm going to use this formula. So in the numerator is 8 factorial. And then in the denominator, 8 minus 3 factorial. So 8 factorial over 5 factorial. And you can use your calculator. Most calculators will have a factorial button. You may need to pause the video and find it. So if you need to do that, go ahead and do that now. All right, and then go ahead and type in 8 factorial divided by 5 factorial. All right, and you should have gotten 336. Now you may see on your calculator a button that says PRB for probability, and you may see, let me get a different color here. You may see this in your calculator. So if your teacher allows that, you can use your calculator to find that. It's up to your teacher and how they want you to find these different probabilities. All right, let's try some more examples. So number 1, how many ways can the letters in the word main be arranged if you use all 5 letters and repetition is allowed? So we're going to be using this top formula. So we have 5 letters, and we're going to be choosing all 5. So my n is 5, and my r is 5. So 5 to the 5th power. That would be 3,125. That's how many different ways you can arrange all the letters in Maine. Number 2, how many different 3-digit codes can you make with the single-digit whole numbers without repeating? So we're going to use the bottom formula. All right, so single-digit whole numbers, we already listed those out right here. We know there are 10 of them. So my n is 10. And we want a 3-digit code, so my r will be 3. So again, you can use your calculator here, or you can use the formula. I'm using this formula here. So 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. And I am going to use my calculator here. And I get 720. All right, pause the video and try 3 and 4 by yourself. All right, and number 3, how many ways can 3 people win first, second, and third place? Okay, so repetition will not be allowed here because the same person can't win first and second place. All right, so I'm going to be using the bottom formula. So I have 3 people and there's 3 different places. So remember, if your n and your r are the same, you can just use n factorial. So I can just do 3 factorial, which is 6. All right, and number 4, how many ways can 8 students sit in 4 seats? So I'm not going to repeat here because I can't use the same student in 2 different seats. They can only be in 1 seat at one time. So I'm using the bottom formula. So I have 8 students and I'm choosing for 4 seats. All right, so n factorial over n minus r factorial. So 8 factorial over 8 minus 4 factorial. Which would be 1,680. All right, let's continue on to combinations. All right, so remember, in combinations, order does not matter. And n is still the number of things to choose from, and r is how many things you choose. All right, so let's talk about when repetition is allowed. So here's the formula. It is a little bit crazy, so I will talk about another way to do this if you're not going to use this long formula. Here's an example. You are choosing lottery numbers from 1 to 20. How many different combinations can you make with 3 numbers? And you can repeat numbers. All right, so my n is 20. That's how many numbers I have from 1 to 20. That's 20 numbers. And then I'm choosing 3 of them, so that's my r. So I'm going to plug it into this formula. 3 plus 20 minus 1 factorial over 3 factorial over n minus 1 factorial. Okay, let's simplify this a little bit. So 3 plus 20 minus 1, that's 22. 3 factorial, here, let me write that a little bit more clear. 3 factorial, 19 factorial. All right, so go ahead and type that in. And you should get 1,540. So the formula is really useful if you have a large number like that. You wouldn't want to have to write all those numbers out. All right, when repetition is not allowed, you have the formula there. And you can use your calculator for this formula. So the calculator, when you see this button, that is only for when repetition is not allowed. And same thing for permutations. If you use this in your calculator, you can only use it when repetition is not allowed. All right, so There are 6 ingredient options for a salad, so that's my N. How many different salad combinations can you make if you choose 3 ingredients? So that's my R. All right, so 6 factorial over 3 factorial, 6 minus 3 factorial, which would simplify to this. All right, so use your calculator. And you should get 20 different combinations. All right, down to the examples. So number 1, how many different lottery combinations can you make from 50 numbers if you choose 4 and you allow repeats? So we'll be using the top formula. So I have 50 numbers and my R is 4. All right, so I'm gonna substitute it into that formula. So 4 plus 50 minus 1 factorial all right, and that's going to simplify to 53, 4, and 49. All right, I'll give you a second to type that in your calculator. All right, and you will get 292,825. All right, number 2, you are making an ice cream sundae. You choose 3 toppings from a menu of 10. So there's 10 total options and you're choosing 3. If you can repeat toppings, how many different types of sundaes can you make? So you can repeat, so you can get chocolate chips, chocolate chips, chocolate chips if you want. All right, so we're going to be using the top one again. So 3 plus 10 minus 1, 3, 10 minus 1, so that would be 12, 3, 9. All right, go ahead and type that in. And you should get 220. All right, number 3, how many different pizza combinations can you make if you choose 4 toppings from a list of 12? All right, so we're not repeating here, so we're going to be using the bottom formula. So 12 factorial over 4 factorial, and then 12 minus 4. So 12, 4, and 8. And you can use your calculator button for this one, the NCR button. And you get 495. All right, pause the video now and try the last one by yourself. Okay, so our N is 20 and our R is 5. We can't repeat people here. So let me plug it in. And you get 15,504. All right, if your teacher gave you this set of notes, you can go ahead and continue. If not, go ahead and stop the video now. All right, so as I said before, the formula for repetition being allowed is really long and crazy, so you may not necessarily need to learn that one. So let's talk about how to find it without the formula. Okay, so in this example, there are 3 flavors of ice cream: vanilla, chocolate, and strawberry. So that's my N. And we want 3 scoops. And we can repeat scoops if we want. So how many different combinations of ice cream can we get? So again, if you are using the formula, there is this long formula here, but you may or may not need that formula. If you can just list them out, you can do it that way without having to use the long formula. But if you do have larger numbers like the example I gave here, you do want to use the formula instead of listing out 1,540 different combinations. So let me show you how to do it without the formula. So let's just start listing out combinations of ice cream. So it says repeats are allowed. So if we want, we could have an ice cream cone with 3 scoops of chocolate. So we can repeat. We can have 3 scoops of vanilla. We can have 3 scoops of strawberry. We could have all 3 that are different. Chocolate, vanilla, and strawberry. We could have 2 chocolate and 1 vanilla. Or we could have 2 chocolate and 1 strawberry. Now, I wouldn't list this as a different combination, because if you have an ice cream cone with 2 chocolate and 1 vanilla, it's the same as having an ice cream cone with 1 vanilla and 2 chocolate. The order doesn't matter. That's not a different cone. All right, I can have 2 vanilla and 1 chocolate, or 2 vanilla and 1 strawberry. Or I can have 2 scoops of strawberry, 1 scoop of chocolate, 2 scoops of strawberry, 1 scoop of vanilla. All right, so let's count out how many that would be. That's 10 different combinations. And just to check it with the formula, so remember the formula says r plus n minus 1, and then r n minus 1. So that would be 5, 3, 2. And if you type that in your calculator, you do get 10. All right, you can stop the video now and complete the practice and check it with your teacher.